Great. How's everyone doing? Last talk, almost happy hour, closing remarks. But yeah, today I'm going to talk about securing ad hoc, mutable, and somewhat mutable or immutable infrastructure as well. I was really excited to hear some talks on security. Jeff had an awesome one about wrapping secrets for containers regarding Vault. And the one this morning in the keynote with Zebia talking about hardening OSs from the beginning was really good. But so what are we going to talk about today? I want to step back and just tell you a little bit about who I am, where I come from, my background. Nuna, I'm sure no one's heard of Nuna Health. We're a healthcare company. We'll talk about a little bit about what we do and some of the things that force restrictions on us, which we have to become creative and deploy things differently than most. We're going to talk about some deployment scenarios after I set the tone, the problem statement. Then get into how Nuna integrates HashiCorp and the Hashi stack in our deployments. Then we're going to talk about changing the game a little bit. I'm going to challenge you to think a little differently in how you deploy things, be it if you're mutable or immutable, how you go about deploying and thinking about security from the get-go. And then hopefully with time at the end, questions if anyone has them. But what I'm really going to talk about is being dynamic to force attackers to change. I run security at Nuna, constantly aware of attacks that are happening. We protect healthcare data. I don't want that to be exposed. I don't want to end up in the news with a data breach. I don't want to go in front of the United States Congress and be accountable for why half of the nation's healthcare data was exposed. But so in forcing attackers to change, I want to hopefully make them loud. By changing the way advanced persistent threats work or organized crime works and trying to attack Nuna, I hope to force them to change to make it so easy for my blue team, my defensive team, to be able to detect that we've been compromised or potentially compromised. But first, so who am I? So I help run the security team at Nuna. More specifically, I own application security and security engineering. Security engineering at Nuna revolves around the automation of security and the tools that we develop to make the infrastructure and our applications more secure. We do things like centralized logging, APIs and libraries, different ways to look up credentials. Before Vault, we wrapped our own secret binary that interfaced with KMS. Just a set note, we're a totally AWS environment, so most of my information here might have context towards AWS, and hopefully you can transcribe that into your environments. I'll talk a little bit about why we're in AWS itself, but I also bring a DevOps side to the team, and I'm actually a bridge into our infrastructure engineering team. The last 16 weeks, I actually kind of left my security full-time position and joined the engineering team so that I could help deploy things and roll out things like Vault and integrate with all of our other solutions better. We operate a high assurance and big data environment, and myself, I come from a diverse background. Before Nuna, I was at Lockheed Martin, which is a Department of Defense contractor for the United States government. There I was an internal consultant covering both internal Lockheed projects, commercial, civil, and government. Before that, I was in the private sector consulting for Cigital, where I did things from AppSec, architecture risk analysis, red teaming, a lot of myself being the attacker, which I try to bring to Nuna day to day so that we can make our applications and infrastructure more secure. Before that, I was back at the Department of Defense at Raytheon, where I did things like anti-tamper, reverse engineering, and when I first started there, I was an embedded developer doing secure development there. And I got my first real view into computing and virtualization when I started at Hewlett-Packard in college, where I was a Category 1 team lead for actually certifying processor virtualization across the Hewlett-Packard fleet. So a little bit about Nuna. I won't take too much time here so we can get to the heart of the discussion. But we're trying to tackle one of America's biggest problems, which is healthcare. And because of that, we contain over 70 million healthcare records in our system. And this is raw records, people's names, social security numbers, what kind of treatment they had, what kind of diagnosis they have, stuff that no one wants divulged or exposed. So our mission here is to gather, learn, and improve. So we're going to gather all that data. We're going to try to form a structure around it so that it's all sensible and we can actually compute across that. We have a team of brilliant data scientists that are actually crunching numbers, using our platforms, and accessing this personal healthcare information daily. And then one of the great things about Nuna is we have a foundational security. It's one of our core values. So everything we build now is from the ground up. I've never had my CEO tell me, no, you can't buy that, or give me a justification of why this costs that much. Go think of a new solution. Can't we use open source? Oh, it turns out we can. We have Vault and HashiCorp, right? But we've never had to actually fight for our budget. It's been really nice to actually have a executive team that recognizes that security should be the forefront of everything you build. And so that's really what I'm going to challenge you guys here today is, as you're building your infrastructure and you're deploying your applications using Terraform, Console, the different integrations of the Hashi stack, think about how you're actually doing that. And when you actually deploy and you plan your Terraform, what are you actually looking for? Are you just looking for your resources to be in the correct syntax, or are you actually thinking about any implications of that Terraform actually being distributed across your infrastructure? So being a healthcare company, we always have to be sure that we're in compliance with HIPAA, the Health Insurance Portability Accountability Act. We also have to make sure that we comply with the government's acceptable risk safeguards. So these are already 2 compliance standards that we have to adhere to. We also have to be SOC 2. We have our internal Nuna privacy standards that we continue to bring up and develop and make sure that our internal standard complies at least, if not beats, the other compliance standards that we have to actually adhere to. And the list goes on and on. As we bring on more clients, they give us, in our contracts with them, they give us other stipulations that we have to adhere to. Our governance, risk, and compliance is a nightmare. But I'm going to show you, hopefully in a little while, how that we kind of integrate all that automatically together. So a little show of hands. Who in the crowd is part of infrastructure engineering or has a DevOps role at your position? Okay, most everybody. Anyone here just an engineering or a software developer? Okay, a few of you. How about anybody from security? All right, I like you guys. Let's have a drink after. But what about any sales execs? I know there's some sales guys because I talked to them at HashiCorp, but I don't know about any other companies here. But anyway, so let's set the tone, the news. Why am I talking about security? I don't know if these apply across international waters or if you guys had much insight to these before, but CSO Online says that cybercrime is much more organized today. There's no such thing for an unorganized cybercrime anymore, and there's such a thing as a digital mob. The US just indicted Iranian hackers that were targeting the US with a denial of service attack. And also, organizations across the world are being targeted with social engineering campaigns. More specifically, 41 were hit with a campaign asking for W-2 IRS information. The recent, Bay Area company that was exposed to this was Snapchat, where their CEO sent one of the HR people an email saying, please send me all the IRS forms of our current employment. And they did. So you now had the whole Snapchat company exposed and their identities potentially stolen. Mattel, the maker of Barbie and those different toys, they lost $3 million for like a day, right? They also received an email from their CEO that said, we set up a new manufacturing agreement. We need to pay this by tomorrow. Please wire this money here. And they did. It's pretty crazy. But the true thing is cybercriminals aren't going away. We're seeing trends that they are continuing to attack infrastructure, attack people, but more so attack companies more strategically and more advanced every year. Is anyone familiar with the Verizon data breach investigation report? So last year, they saw a significant increase in attacks, and they also saw an increase in attacks across countries. So this year, there were 61 countries that were actually attacked. This is the slide that I want you to pay particularly attention to, because everything I'm going to talk about from here on is going to relate back to this slide. So the top line is time to compromise. So from the time that an attacker actually starts to attack an infrastructure, be it through network attacks, application attacks, social engineering, this is the amount of time it takes to compromise within days or less. So 75% of the time, starting in 2004, they were able to compromise a system between days or less. And when I say compromise, I mean just the fact that they got a foothold. Doesn't mean that they're actually doing anything yet, but they're able to plant themselves in a system somewhere, be it an end user's laptop, an actual system on a server, server-side system, or it could be like the heart of gold in a database somewhere. But they're just going to sit there for the most part because they don't want to be loud, they don't want to be noisy, and this is what we're going to try to force them to do. But if we look in 2014, it's almost at 100%. The attackers are getting better. I don't know if users are so rushed or so stressed that they're not thinking before doing things. But how can we solve this? The most disturbing factor of this is the time to discover. Only 25% of the time last year were we able to discover that someone compromised our systems in the same amount of time that it took them to compromise ourselves. That's really disturbing. And it's the way that advanced persistent threats work, is they will actually sit on a system for hours, months, years, before ever doing anything. So when I worked at Raytheon, we're attacked by advanced persistent threats all the time, right? We had some that sat at either our infrastructure or subsidiaries that we would acquire. They'd sit in their infrastructure for years. And a year and a half later after we acquired them, they'd make their move. So they might be sitting on things that they potentially think companies like Raytheon or Lockheed or any of the companies y'all work for will acquire just to wait for the time that you bring them into your system, and now they have network access that they wanted. The next slide is actually showing the number of attacks total across industries. Now, Nuna, we're interested in this because the number of healthcare attacks continues to go up, and the number of data breaches in the healthcare continues to rise as well, which is very disturbing. So the lack of detection or compromise or of exploitation continues to be a problem, but how can we change this? So I'm going to talk about 3 deployment scenarios or landscapes that I'm just setting here. They could be a comprehensive list or not. The first one you guys probably won't care about because this is all cloud-based, and I'm going to talk about the traditional old-fashioned, like what you would see at Raytheon or Lockheed Martin. And then we're going to move into the dynamic cloud, and then what I called like the really dynamic cloud. So first, the current. And we'll step through this really fast because I know it's boring. But they own and lease their own hardware. You create a standard image. You use CloneZilla or another tool to ghost everything out, right? You have this one magic image that gets applied across all hardware. You might do some manual installs on top of that. Most companies are actually Active Directory based, right? So they have a Windows Active Directory system that probably once they stand it up, the only time it gets upgraded is if a new release comes out. And so say from 2008 to 2012 on the Windows Active Directory side. But even that upgrade might take years because of the risk of things not working when they make that upgrade. We have firewalls, switches, routers, VPNs to be able to allow remote access. We all know that in the cloud world that we all have VPNs because that is needed. But then they have DNS. But let's move into the more interesting things, which we have the cloud-hosted enterprise development environment or deployment. So, of course, we have cloud instances, network security rules. We, of course, have our VPN. But keep the VPN in mind later on when I talk. Like, are there scenarios when you always need that VPN on? We'll talk about that a little bit later. Most likely, you might have Windows AD as well, or an SSO solution. It could be all provided through Google Apps and Google OAuth, allowing yourself access to different applications and instances through SSH. However you guys might do that. Of course, you have, there we go, Route 53, or maybe Cloudflare to protect the IP of your instances and protect yourselves from dedicated denial of service attacks and different various attacks using their web application firewall. We have configure management, right? So we're a mutable infrastructure per se. So we're going to stand up an image off of a base image. We're going to configure it with Chef, Salt, Ansible, Puppet, whatever you want to choose. But we might manually deploy these instances. They might be Terraform controlled. Since AWS, we do a lot of CloudFormation as well. So they might be controlled with CloudFormation. Or you might have a mixed bag where not everything is controlled via Terraform or CloudFormation. But you might also use Packer, right? We had that conversation this morning about hardening your image with Packer and then using that base image to build other things, right? You only need to take that 20-minute Packer hardening step once, and then you can fast forward and start configuring with Chef or whatever you want to use. I think it was Ansible is a popular choice here. I saw a lot of presentations using it. But let's really take a step at what I call the dynamic cloud deployment. Once again, we have cloud instances. In our case at Nuna, we're AWS solely. This is because the cloud, or AWS will sign BAAs across many more platforms than other groups. Like DigitalOcean, from the get-go, we're not allowed to operate there. We have dynamic security rules. So you might not necessarily have routes all the time. You could spin up instances and those routes be spun up at the same time. We have VPNs. These VPNs may exist all the time, or they may not. We pack our images, and we pack every image. We have on-demand instances. This relates back to the VPN that I mentioned earlier. Route 53 or Cloudflare hosted zones. So we're controlling everything via API, via Terraform or CloudFormation or other tools. We're 100% configured in these automated tool sets. So at any point in time, we can look at our Terraform state, our CloudFormation templates, or actually go into consoles and see what is actually out there and what we deployed. So at any given time in code, I can tell you what we have deployed and how it's configured. We also have Windows Active Directory, SSO, Google Auth. All those things might still exist. Just because we're in the cloud doesn't mean that we have to, X these traditional leased and owned hardware things to get rid of them. There's ways to do it, and there's ways to do it securely. One of the things we do at Nuna a lot is, very DevOps. We have blue-green deployments. We have a blue instance running. We'll spin up that green instance, make sure it's tested and approved and hardened before we actually deploy that out into the system, and then we do that instance switch. We have continuous redeployment, and this is key here. I want you guys to remember this when I go to a couple slides from now, and we talk about some specific things at Nuna that we do. But continuous redeployment is key both in the immutable and mutable infrastructure deployment setting. We'll talk about why in a little while. And then once again, we have configuration management. And this is what, Chef, Ansible, the different variations. I think there's always somebody trying to do it better. There'll be new companies spinning up soon, I'm sure. But one of the other things we also added this is Vagrant development environments. And these environments specifically address each role or application within our given infrastructure. So we don't have a one-size-fits-all Vagrant environment. We have one Vagrant environment per application. So one of the things that's really important in order to make sure your environments are secure is really knowing and trusting your cloud provider or providers. Right? It's really nice with HashiCorp to be able to distribute your load across cloud providers. But make sure you really understand what things mean when you're actually addressing your cloud providers. Have those conversations. Get those agreements in place so you can see the underlying workings and how things actually are implemented. Does dedicated tenancy truly mean dedicated tenancy? Is it like Packet where you actually have a bare metal system? Or is it AWS where you're dedicated tenancy and we're just going to tell you that you have your own environment, which is true, right? They've gone through audits. They are capable of running dedicated instances. And at Nuna, we're 100% dedicated. We're not allowed to share tenancy with any other users unless it's one of our AWS accounts. Is your network actually trusted? What does it mean when I'm setting up network rules and when I have private internal routing? Or does the cloud provider provide private internal routing at all? How does one network across regions? Is that secure? If you're detecting cross-regional traffic, would you trust that by default, or do you have to investigate a little bit more? What kind of things do I need to put in place if I have my infrastructure spread out across the regions? Do I need direct connects? Do I allow AWS or the ISPs to route it like they want? How does that work? When we talk about availability zones, right, we're designing a high availability environment. What does the networking mean there? In AWS, it actually means that across US West 2, availability zone A, B, C, they're actually direct connect communications. So connection from A to B never leaves Amazon's environment. So by default, can we trust that? We could probably trust that more than we can trust the network connection coming from a different region where we might need to do a little more scrutinization. And then what agreements will they sign? In our case, we're always interested in BAAs. We also have a government side where we have to worry about FedRAMP and other things. So the list goes on and on. But mainly for developing a secure environment from the beginning, you need understand the underlyings of what you're doing. Who uses open source software with actually looking at the open source software to see if it's doing anything malicious? Anybody? A couple, right? If you had more time or resources, would you dedicate to that, or are you guys not worried about it? Don't want to tell? It's okay. But let's take a look at how HashiCorp is actually integrated at Nuna. The first most important piece for me, the security guy, is Vault. A lot of fun announcements today that I'll be going back next week and implementing myself. But we heard a lot of talks about secret storage today. And it was really cool to see Kelsey do a demo in his test environment of actually showing Vault with a MySQL backend to manage users and passwords. If you don't do this already, I recommend it. It's really great from an accounting standpoint and auditing standpoint. You don't have to say, yeah, oh, we forgot to roll that password every 90 days, or whatever your compliance might say. Vault does it automatically for you. So we look at API tokens, third-party service account passwords, whatever we need to store that we feel are secrets, keys to SSL certificates. We have other certificate management applications in place at Nuna as well. So we may or may not store everything in Vault. But we use it as a database password backend. It controls all of our MySQL and Postgres users. Since Redshift is Postgres-based, you can use it for that as well. I'm not sure if anyone's doing big data within Redshift. We also use it as an SSH debug key managed by Vault. So who knew that Vault, you could actually negotiate SSH creds to systems? Hopefully a lot of you. We got some hands. But so one of the things that we do at Nuna is when we deploy a server, the key that gets deployed on that server is actually a key controlled by Vault. And so if you need to SSH into that server, you actually have to ask Vault for permission and have them set up that SSH access for you. We do this because one thing, we feel you shouldn't need to go through an SSH to every instance. That's why you constantly redeploy and you pack and you have configuration management tools. But also it controls things like this instance has been running a long time and that guy that left the company, his key is the debug key. Like, how do you switch that out, right? So in our Vault deployment, we have an authentication backend for the users, and then we created an AWS backend that we're now going to go switch with 0.6 in the AWS auth backend. But we did, the cubbyhole limited token, life token approach that this new AWS backend solves the auto-scaling problem that everyone's aware of. So next week I'll be deploying that. But we also use AWS mounts, which are really interesting in the HIPAA environment, in such that if we have client data in our S3 buckets, just because I work at Nuna doesn't mean I have access to that client data. So we can use Vault to manage our AWS STS tokens to give us per bucket permissions if we need to access production data, raw files. And then we can go back and audit all those different rules, who accessed it. Eventually in the future, maybe we can get two-man acceptance for audit. So if you need access to this client, two people have to say you can access that and allow us to do it that way. But we can go very granular in our policies within Vault for managing how people get access to our AWS environment. And this allows us to manage it all and be configured and not have to necessarily worry about the roles that we define within the AWS IAM environment. And of course, we have audit enabled. And if any of you have actually played with the audit backend of Vault, you can get some seriously private data in there. Has anyone ever run the Vault audit backend without HMAC and seen your LDAP and AD creds are being sent in the clear? It's pretty terrifying. So make sure you have audit enabled and you're doing it securely such that no other person can see that information. So next, Packer. We're very similar to a lot of people here. We pack all of our base images. So we have a base configuration that all of our images inherit off of. It's really important that we have this base image well-defined from our security concerns and central services. So by default, you're going to have things like logging to Splunk, access to certain servers, everything. We split it out by roles. So we have a base image, and then every application gets a role which inherits from that base image. We have our standard configurations for being able to talk SSH, which negotiates permissions over Active Directory, Nginx configurations, logging, and then accountability. At any time, we can actually do an audit of our Packer files to see what's actually being installed per application. There's no such thing as manual installation in our environment. Here's an example of how we have it, kind of our structure. We have a base image, And then we have roles. So like our front end's a different role, Jenkins, and in this case, Vault. And one of the cool things about packing here is once we pack an image, you automatically get a Vagrant and an AMI. So you have a standalone Vagrant environment for you to test things on. So that leads us into Vagrant. When you're actually deploying in an environment and developing across that, you actually launch your Vagrant image. We have a master Vagrant file where we've done our best to try to eliminate collisions on ports and forwarding like that. But every time we build an environment, it builds both a Vagrant and a AMI for IAM. And one of the fun things is we accidentally filled up the Atlas build queue because we had a bug in our Jenkins. And so every code commit was triggering a Vagrant build, and they actually nuked our account. It was pretty fun. But Terraform, we don't use it too much. We wrote our own tool called CF-Run, but we're starting to integrate Terraform more and more. We have an entire VPC that's controlled by Terraform. We have an entire VPC that's controlled by CloudFormation. And then we have other VPCs that are what we call dirty, and we can't wait to light them on fire. But as everyone knows, with Terraform, you control EC2, RDS, IAMs, S3 buckets, DNS. We try to make things secure from the beginning, so we have templates that people can use when they're trying to CloudForm or Terraform things. So here's an example where when we actually CloudForm our S3 buckets, by default, we get a policy applied that you cannot upload unencrypted files. Here's an example of a security group, which in this case is bad by the Nuna policy, such that it's actually being passed a CEDR and not a security group. And then also, if you don't understand the underlyings of how things work, with AWS, if you actually CloudForm a security group and don't necessarily explicitly say an egress rule, you get all egress by default. So you might look at something and say, oh, this doesn't have egress, that's perfect, and then not know that that instance is open to the world for outbound. And that'll be the first thing your attacker finds. So force change, be secure from the beginning, and be always moving. So here at Nuna, these are the things that we actually do and put forth across our infrastructure. So it must be push-button deployable, which means it also must be redeployable. So just because you deploy an image once doesn't mean that image should be living out there running full-time without being redeployed. Who in the audience patches instances by running an Ansible playbook? I need to go upgrade OpenSSL so I kick off an Ansible playbook, right? Is there a security problem there? Probably not, except that if you didn't reboot or redeploy your system and build it from scratch, you might not necessarily be getting rid of a problem that you don't know about. If an attacker compromised that system, they could be sitting there doing nothing, and your patching of OpenSSL doesn't do anything because they already used that vulnerability that you're patching against you, and they're sitting there waiting just to make their next move. But if you redeploy and build from scratch, you eliminate that threat. So this is where I challenge you guys, is rethink your deployments and see, where should we redeploy? What are our critical assets? You know, we have both state and stateless stacks. You know, some things make it very hard or very easy to redeploy. Some things actually hold state in file systems, so then we have volumes that we're actually protecting and having to snapshot and make sure we don't lose. We're blue-green, we're on demand. In some of our environments, we have VPNs that are only up when we need to go in and actually configure things. Otherwise, we tear those VPNs down and they're never up. So we eliminate that one attack surface from the attackers. We do code review, and in code review, we're not just looking that the syntax is correct. We're actually looking in and saying, does this make sense from security? With compliance, once we pack images, we have Jenkins builders and workers that actually launch those images and run automated tools against those. We'll see, we can run the STIG checker, any automated tests that we want to run to see if our instances are actually in compliance and secure enough to be deployed. I mentioned a deployment server. Our security groups, we said no CEDRs across the board. We have exceptions like GitHub when we need egress to our GitHub service, right? We know they're CEDR. But if it's not a by default explicitly expressed CEDR, then we have to do some other things. But instance to instance, instance to database, vice versa, it's all security group referenced across VPCs, across counts. Nothing is CEDR-based in our new environments. Instance health checks. Are they stale? This is where we talk about the redeployment factor. How often do I redeploy? Is that instance greater than 30 days? When you patch your Microsoft AD server, why not just redeploy it? We actually have a blue-green deployment of our Active Directory server. It's pretty crazy. But we redeploy our systems with upgrades instead of patching. And that helps us eliminate any potential compromise that we don't know about. And then resource tagging. When we SSH into systems, we actually mark them dirty. And then we have automated queue jobs that will go detect every dirty instance and redeploy those automatically. And also resource tagging. If I want to see for auditing what commit hash built this image, I can go look and find that actual AMI and pull that up. So wrapping up, please be secure from the start. Think about not only how can we grow at scale, but how can we grow securely at scale. So do secure code reviews. Don't just look that the syntax works and that when you run Terraform plan that it doesn't destroy anything. Look at what it's actually doing to your infrastructure and how it's opening you up to attack. We developed custom linters and tools that allow us to not be able to check in rules that allow egress to everything. You have to have explicit exceptions to be able to do things like that. So we catch those before they're actually deployed, which is kind of nice. And then tighter security groups. With doing cross-reference security groups, we don't allow bugs or mistypes in a seeder that allowed access to my EC2 range plus Datadog's EC2 range, something like that. But force attackers to change. Force those APTs to modify their tactics, which is going to make them uncomfortable. It's going to make them loud. Sure, they'll eventually get to where they can move faster, but we're going to have some time to be able to detect them better. So redeploy your instances. Regardless of if you're mutable or immutable, redeploy that base image so that you can make sure you're secure and rid any attackers that might have compromised your systems. On-demand instances, think about, do your instances always need to be up? Do you always need those network rules, or can you deploy those only when needed? And most of all, granular IAM permissions. Does every instance have access to everything? Do your production servers have access to your dev servers and vice versa? Think about those things, and I challenge you to go rethink how you deploy things and how you can strengthen your security posture by using the awesome HashiCorp toolset. Are there any questions? Great. Thanks, everybody.
Thank you very much, Will.